Good afternoon, everyone. I'm Stuart. Welcome to this webinar. It's a sunny afternoon. It's an afternoon that we're all going to be enthralled because we're looking at one of the most sort of important sort of topics that we've looked at really around networks, around flexibility, looking at the whole kind of technical side of where things are going in that. And I think one of the things that's been really, really obvious for everyone is how important our networks are. We've seen it with the recent storms. I think we've seen it tragically with what's going on in Ukraine and Russia with the Russian invasion. Without our networks, without our power system, then everything grinds to a halt. So I think this webinar is very important for that. I have two fantastic speakers for you. In fact, I have three, but one will be a silent partner. I've got Simon Brooke, who is the business plan lead for Electricity Northwest. Hello, Simon.
Good afternoon.
And I've got Chris Collins, who's from Baringa Partners, senior manager. Hello, Chris.
Good afternoon, everyone. Hi.
And also our silent partner, who's there, but in spirit, as we haven't got the camera quite now, Dr. Avi Afital, who's a technical lead on ENA's Open Networks program.
Hi, Sumit.
Hi, how are you?
I'm good, thanks. And like Sumit mentioned, I'll be in the background to take on any questions in the wider program if necessary.
Brilliant. So ladies and gents, if you've not used the BrightTalk platform before, it's pretty simple. You'll see there's an area for you to type in questions. Please do so. We're going to have a presentation that lasts about 40-50 minutes, but during the presentation there'll be two polls where we'll ask you to take part. We'll also be looking for questions throughout. So Simon and Chris are more than welcoming to you to have questions. That's what we really want this to be. This is not about you listening and just having a lecture from these guys. It's about you participating. So please put your questions through. We'd like to remind you to rate the webinar once you've had a view of it. You'll also be able to download it and watch it at your leisure. So before we start, Simon, can you just introduce yourself briefly on what you do at Electricity Northwest, please?
Yep, my name's Simon Brooke. I work for Electricity Northwest. I was one of a small team who wrote the DSO business plan for Electricity Northwest that we submitted on the 1st of December. And the reason why I'm part of this webinar this afternoon is I am the product lead for the common evaluation methodology and tool, which we'll be discussing this afternoon.
And Chris, a little bit about yourself and also Baringa, please.
Sure. So Chris Collins, I'm a senior manager at Baringa Partners. We're an energy consultancy, a management consultancy more broadly. I've personally worked on a range of flexibility and innovation projects with a range of network companies, and specifically I've been working for the past 2 years supporting the ENA on the development of this tool, so which is why I'm in the room.
In brief, guys, before we get into the details of it, energy flexibility, frankly, that is our future, isn't it, really? If you look at where we're going, we are looking at the mass transition, the electrification of transport, electrification of our heating, and the way that we'll be, as consumers, whether we're businesses or domestic consumers, it's about balancing using flexibility. Is that the reason that this is such an important topic? Simon?
That is absolutely right. There's lots of studies in GB and around the world that shows that if we do not embrace flexibility, we won't achieve our 2050 net zero targets at minimum cost.
I suppose, Chris, the thing about flexibility is, in a way, it's delivering without building, because that's the one thing everyone talks about. You can't keep putting more cables in the ground. The cost of it would be just enormous. The idea is letting us as consumers, prosumers, whatever you want, help to take some of that load so we build what we need to.
That's absolutely right. I think it's both the cost of going down the building route would be so high, and also it may not even be physically possible to do that at the rate, given the rate of change that we're seeing on the network. So flexibility is definitely a tool to manage that transition, and it's going to be particularly important given how uncertain the uptake of different technologies is going to be, and the location-specific nature of that uptake. which is exactly what we're going to be talking about today, is sort of how that uncertainty feeds into the value of flexibility.
All right, well, enough about me and giving you the background. I'm sure the audience is very well aware of what's going on with common evaluation methodology. Let's go and hand over to Simon to take you through the presentation. And remember, ladies and gents, there'll be a couple of polls at certain points where I'd like to get you involved. And please do, as you go along and you listen to the presentations, then please do ask questions. Simon, let me hand over to you.
Great, thanks, Sumit. I'll just start slide deck. There we go. So welcome everyone, and good afternoon. This is the webinar that launches our valuing optionality consultation on the common evaluation methodology. So on today's session, I'll do the intro and the background to the common evaluation methodology. Chris will cover modelling, flexibility, option value, and then the alternative approaches. And then I'll wrap up the end on the consultation and the next steps before we move into question and answers. But as Sumit said right at the beginning, there'll be a couple of polls all the way through, and there will be points where we will stop and take questions. Because this webinar is launching the consultation, you'll see embedded in the slides questions. They are questions that are in the consultation paper. So we won't be covering them in particular, but you'll know at various points what questions that we'll be raising as far as the consultation, and give you an opportunity potentially to ask any questions at the various breakpoints that we've got. So with no further ado, I'm going to move to the first slide. And there's a reason why we named it the common evaluation methodology, and that's to create a consistent approach for the DNOs to evaluate network solution options. And the tool was primarily developed, or its primary use case was to do that comparison of flexibility against traditional reinforcements. And that is in essence why we developed it. Because several years ago, when we as DNOs started to look at how we would find alternative solutions rather than building assets, we each had various different approaches. And when we came together at the back end of 2019, we realized that we virtually had 6 different approaches between us, and therefore there was a need to create a common approach that we could all use. So we had a consistent way, and there was some security in and transparency of what the decisions that DNOs were taking. So in 2020, we launched this product called the common evaluation methodology, and with the help of Baringa, the product team developed what we now call the methodology and the tool's an Excel model, and that was published with a whole range of materials at the end of 2020. And as we moved into 2021, we picked 2 particular further developments, one around value and optionality, and the other around carbon assessment. And the work that we did in 2021 on value and optionality is really the source of the consultation and the webinar this afternoon, because we're really looking for some feedback from all of our stakeholders to actually get into a concept debate with us about whether we have done enough on valuing optionality, or whether we should do more by using alternative approaches. So all of the materials for the Chem tool are available on the ENA's website on their resources library. You'll find the methodology statement, the user guide, the actual Excel model itself, and then how to use videos, as well as a set of use cases. So we've published all of that. It's available for everyone to go and have a look at. So let me just spend a bit of time explaining what the actual methodology is, in particular the tool. So you'll see on the graphic in the bottom right-hand corner, that's the first tab of the Excel model that we have. It is based around the Ofgem CBA. So for those who are in the industry, because we are a regulated distribution businesses, we're required to use the Ofgem CBA tool when making decisions. So as this is an aid to decision making, it's a tool to aid decision making, it's based on the Ofgem CBA. And what it does do is it allows the user, primarily the DNOs, to actually look at the costs and benefits of the solution. And it allows us to do a number of evaluations, whether that is a simple flex against traditional reinforcement or potentially any other alternative innovative solution. It has been constructed as an aid to decision making rather than a decision making tool, and it provides us quite a lot of insight. So it will give us things like ceiling price and output, what we think is the optimal contract length as well. So the DNOs use this and a few other pieces of information to aid the decision when we're going to make as far as investments are concerned. Okay, so that's all I want to say. I'm going to hand over to Chris, and he's going to jump particularly into how we model flexibility under load growth.
Thanks, Simon. So yeah, we just wanted to give a bit of a background to how uncertainty has been modelled in the Sem tool and some of the thinking that went into that original decision. So taking a step backwards, just to note that prior to the development of the common evaluation methodology, the DNOs, as well as having their own individual ways of accounting for flexibility, in general, that evaluation was based on a single deterministic load growth scenario that was determined, that was used to calculate the value of flexibility, as opposed to conventional forms of network intervention. And because it was deterministic, there was no low growth uncertainty captured in that modelling approach. So the value of flexibility that therefore came out was just really primarily based on the value associated with deferring reinforcement for a number of years, along with some additional benefits associated potentially with loss reduction, carbon benefits, and also other benefits such as reduced outages for consumers. The decision was taken to move towards an approach that let you look at multiple scenarios simultaneously, and this is aligned with the DFES, the Distribution Future Energy Scenarios methodology, which itself has evolved from the ESO's FES framework, and by modelling multiple scenarios sort of in a single tool, it lets you explore how that flexibility value changes for different load growth scenarios. And what it also lets you do is as well as sort of considering the value under each of those scenarios individually, it lets you look across scenarios and consider some strategies such as least worst regrets or weighted average that lets you say, if I do flexibility versus something else, what am I expecting the outcome to be, given that I am in a state of uncertainty about what the future looks like. So that's an improvement if you're looking at making sure that uncertainty is reflected in the tool. But it's worth noting that all of those scenarios, and this is consistent with FES and DFES, all of those scenarios originate sort of in year zero. So there is, once you're on one of those paths, as far as the model is concerned, it is again deterministic. So that uncertainty beyond year zero, it sort of disappears, if you like. This led some to sort of challenge that approach and argue that really to model uncertainty properly, you should have uncertainty at various points along that future trajectory. And so this is sort of illustrated in the chart on the left, where you have additional branches, and of course in reality there may be many more branching points on those scenarios. So that's really what we're going to be talking about today, is sort of whether that is an appropriate thing to do, how it might be done feasibly in the context of the Sem tool, and what additional value that may give to flexibility if we go down that road, and in order to get your views on sort of whether that's an appropriate thing to do and whether it adds value. And just to note that whilst there are, this approach describes different branches, there are multiple ways of sort of getting to that point. So you could, for example, model those branches in a sort of purely stochastic way. So sort of you do away with scenarios as your sort of basis, or you can use scenarios as the sort of the framework around which you add additional branches on top. Or some sort of hybrid where you're adding a stochasticity around some existing scenarios. So we'll explore some of those approaches, and the idea of it being that we can get your views on what's appropriate. Yeah. So just to reiterate, where the Sem tool is currently, it lives in the middle case here, where we're using these scenarios branching from this origin point, and what we would talk about as part of this session is sort of where uncertainty value is reflected in that tool under that framework, and where option value comes out, before we then move on to adding in those additional branches. So before we sort of get into thinking about option value with that branching structure, we wanted just to make sure we understood sort of as a group where uncertainty is reflected in the Sem tool, and how that translates into option value in the tool as it currently exists. Before we do that, just to make sure we're all sort of on the same page when we say option value, it's a term that exists in a variety of industries, most often probably in financial circles, and simply put, it is the value associated with having the right to do something rather than the obligation to do something. Another way of looking at that is it's the value that comes from being able to wait and see whether you want to do something in the future, and that ability to wait and see is what flexibility gives you, and the value of that flexibility is higher typically when the future is uncertain. So if you know what the future holds, there isn't really any value of waiting and seeing, because you know what's going to happen around the corner. But as you become more uncertain about what the future holds, and the value of different options, a relatively cheap option that lets you peek into the future has value associated with it. So to use that financial terminology, the way we'll typically be talking about this is there's an intrinsic value of flexibility, which is the value that flex would have in a deterministic world. And then there's an extrinsic value or an uncertainty value on top of that, which is associated with the uncertainty itself. And that's sort of how we'll try to separate those two concepts. And you can think of the total option value being as the sum of those, so that deterministic value and the uncertainty value on top. I mentioned that the tool lets you look across scenarios, and that's really important. So if you're only looking at the value of flexibility under individual scenarios, sort of scenario by scenario, that doesn't necessarily help you make a decision as a network operator or anybody else using this kind of approach, because you need to be able to make a decision whilst in a state of uncertainty. You don't know which scenario you're on. So the outturned low growth might be one where flexibility has inherent high value, or it might be one where it has relatively lower value. You won't know which of those worlds you're in. So what the tool lets you do currently is to model up to 10 low growth scenarios simultaneously. The value under each of those, but then and you can do that in two ways. You can either say what is the value of flexibility over and above conventional reinforcement, say, or it lets you sort of flip that on its head and say what is the value of flexibility, what is the price of flexibility beyond which flexibility no longer makes sense as the thing for me to procure. So there's obviously a sort of theoretical limit. As flexibility gets more expensive at some point, it ceases to be the optimal strategy. So what the tool lets you do is to explore that ceiling price. But as I say, the best strategy is not necessarily clear cut, because it depends on what you're trying to optimize. And there are potentially lots of different ways of looking at this, but the two that the tool lets you explore are one is least worst regret, and the other is weighted average. So least worst regret is an approach that is used by the ESO as part of the NOAA process. It's used elsewhere. It's fairly well established. And the idea here is that you're defining a concept of regret, which is the difference between the net present value, or the value that you get under a particular scenario, versus the maximum value that you could have achieved. And what you're trying to do with least worst regret is find a strategy that minimizes the worst regret that you could experience. So it's quite involved to calculate, but sort of conceptually, what you're trying to do is is avoid bad outcomes effectively. The one advantage of that approach is that you don't have to define probabilities for each scenario, which is why it's sort of quite useful when you're using scenario-based approaches, because typically you don't define probabilities when coming up with scenarios. They're sort of intended to be internally consistent possible futures. But there are downsides that I know are being explored in a number of areas. And so one is, for example, that the strategy tends to be driven by the more extreme scenarios, so your bounding scenarios, which may or may not be appropriate. The other approach is to just assign probabilities to scenarios and take a more sort of simple weighted average across scenarios and say, given those weightings, what do I expect to get in terms of benefit out of doing flexibility rather than doing something more conventional like reinforcement? There are benefits to doing it that way, but a critical point is that you need to define those probabilities, and there isn't currently a standard way of defining probabilities for scenarios. So that would need to be something that is discussed and agreed upon, and indeed that's one of the consultation questions here. Is should there be a common approach to defining these probabilities in the Sem tool? And we're certainly open to get some views on how those probabilities should be defined. And yes, we're open to, in particular, if you could refer us to any published work that could guide that. I think that the ENA would find that extremely useful. If I can click on, hopefully, yep, there we go. So I think this probably just recovers what I've just gone through, but this is visually what you get in the Sem tool. So as you can see here, these are two outputs that you get from the tool. You can run the model to test flexibility under these different scenarios. So for illustration, we've got 5 scenarios. These are all dummy numbers, by the way, but they should give you an idea of how the tool runs. And what it tells you is 2 things. One is, under each scenario, what is the optimal duration of flexibility that you should be looking to procure, and that will be a function of the price of flexibility and the volume of flexibility you need to address a network constraint or similar network need, and that varies across scenarios. And also, what is the NPV, the net present value, the value of that flexibility above conventional reinforcement for that length of flex contract. And there are big swings potentially in the value of flexibility and the duration of flexibility that continues to make sense. So, in this illustrative example, under your sort of central best view, it may make sense to do flexibility for a couple of years. Beyond that point, again, using these dummy numbers, the cost of flexibility and the volumes of flexibility you would need to manage a constraint go above the value, the cost of just reinforcing at that point. Whereas there may be scenarios, such as in this community renewables example, where flexibility continues to make economic sense for a long time, and that may come about, for example, if you need flexibility in the short term to address a particular constraint, but potentially energy efficiency or rooftop solar PV uptake picks up, and that need for flexibility, that need to manage a local constraint goes away, and in that case, you haven't just deferred reinforcement, you potentially avoided it altogether because you've got over the hump where you would have reinforced, and instead you've done flexibility just to get you over that hump, and in the grand scheme you've paid very little for that compared to what you would have paid for reinforcement. So there are these large upsides potentially, depending on sort of how you parameterize this, and the more uncertainty is, the higher that value of flexibility can be. And then finally, so in terms of how this is represented in the tool, as I mentioned, we have, this is an update that came in at the end of last year. The functionality hasn't really changed, but what we've done is we've made it clearer the distinction between that intrinsic benefit of flexibility, which we're here defining as the value of flexibility under the best view, and separating that from the uncertainty benefit, or the extrinsic benefit, if you like, which is that additional value that you get because there is scenario uncertainty. And that uncertainty benefit will depend on whether you're choosing least worst regret or weighted average, but conceptually that's what those two bars mean. And then the total option benefit is the combined value of flexibility, both intrinsic and uncertainty benefits. And again, we have a couple of consultation questions there. So this represents the update that has already gone into the Sem tool, and we just want to make sure that that is consistent with your collective expectations. And do the changes related to valuing optionality, specifically provide you with a view and understanding of that option value and flexibility. So any thoughts you have on that would be appreciated.
Right. So thanks very much for that, Chris. We've got a poll that comes up now. So this is the first poll, which I'm just going to start now. Just if you're new to the platform, it has a very weird quirk, I'm afraid, ladies and gentlemen. But you won't be able to vote for it unless you exit the expanded view. So if you're on full screen, take it back to sort of normal screen, and you'll see a poll that's just gone up. So the poll asks you, does the 2021 revisions to the CM and tool deliver what you expected, which is the question you used there. Yes, no, valuing optionality doesn't meet my expectation. No, carbon impact doesn't meet my expectation. No, neither valuing optionality or carbon impact meet my expectation, or don't know. You can vote now throughout this next few minutes. So if you like to use that now, ladies and gents, I'll keep it open for about a minute or two. Just vote whenever you're there. While we're doing that, guys, I'll just take a little break from the slideshow. A couple of questions come in, which I wouldn't want while we're waiting for people to ask questions to answer the poll. Let me just throw this one. Someone's asked, can you briefly recap on the definition of the ceiling price and how it's useful to the users? Now, I don't know who wants to take that. Avi, do you want to take that one?
It's probably better Chris does, I think, Summit.
Okay, Chris, go for it then.
Okay.
Chris is looking really happy as if he's been put in the corner by Sir. Chris, you've got 30 seconds now.
30 seconds on the ceiling price. So the ceiling price is the maximum value of the maximum price, of flexibility, that as far as the tool's inputs are concerned, the maximum price where flexibility is still the right thing to do. So whatever the minimum contract length for flexibility is, say it's 1 year, as long as you're below that ceiling price, it's still the optimal thing to do is to do flexibility, subject to those inputs that you put in. So it's not a definitive answer, but it lets you explore how the value of flexibility moves with those input assumptions.
And another one, I mean, will all DNOs use this chem tool? If so, is this used in business plan submissions? How will it work?
So I'll take that one. Yes, all the DNOs agreed to start to use the chem tool from April 2021. So the majority of DNOs actually have biannual tendering processes for purchasing of flexibility, generally spring and autumn. And you'll be able to see the results of the uses of the chem tool on the various DNOs websites, because they are all committed to publish the chem tool once they've made a decision. I am aware that a number of DNOs use the chem tool as part of their submissions to the regulator for their RIO ED2 process.
Yeah.
I'm not aware that it was all of the DNOs. I'm only aware that some of them did.
Yeah. And one more before we head back to the poll. This is quite a technical one. Again, I'll leave it up to you to decide who answers this one. Without using pure scholastic demand, really good audience today, you are always limited by having to estimate scenario probabilities, which are purely subjective. And I did wonder that actually as you were going through that, Chris, because you talked about kind of you're making these probabilities. From what I remember, that my old mathematics, a lot of that is kind of best guess scenario. So what's the answer to that one? Are these purely subjective sort of scenarios that you're coming up with?
So I think the scenarios aren't subjective, but they are intended to serve a particular purpose, which is to explore possible plausible futures and to make sure we're planning against them. Maybe the challenge we're facing now is that we're having to think about using those scenarios to do something a bit different, which is to assign value to flexibility standing today when we are uncertain about the future. So I think it's a fair challenge and that's exactly the question we're exploring here, is whether those scenarios can be used for this purpose, and I think you would have to assign some probabilities, or whether we do need to rethink how we and how to square that, because I don't think scenarios are going anywhere, but maybe they're not exactly, you know, in the long term the right thing to do. But that's for the consultation.
Yeah, I suppose you know, you're trying to build this as you get more data, you'll be able to make it more accurate, isn't it?
Yeah, and defining probabilities is going to be subjected to a point, but if we're looking for commonality across DNOs, if some consistency so that the market can understand how these things are being valued, that's a challenge, because yeah, we need to get away from just picking numbers that feel right. We need to have something more systematic than that.
All right. Well, look, I think we've given the poll enough time, so I'm just going to end it now. So, in conclusion, the overwhelming 60% don't know. There you go. 26% said yes, 3% said no about the value of optionality, but 60% a whopping don't know. Feel free to review more and respond directly to Open Networks. Well, there you go. We've got that. Chris, let me hand back to you so you can continue with your presentation, please. Thank you.
Thank you. So, if I click on that.
Slides. If you launch slides again. There we go.
Let's see. Magic. Okay. Unless I'm mistaken, these slides will be available after this session. So with that in mind, I'm going to go reasonably quickly through the next section.
Yeah, everything's available. It'll be available for to watch again and to download, and we'll have links to the Open Networks and ENA, so no problems.
Brilliant. So this section is going to be a little bit hand wavy, as I sort of just run through some of the logic that we've sort of gone through as part of thinking through how we might take this model forward. Take a look at the slides offline and feel free to give it some consideration before you respond in the consultation. But we thought this might be useful just to kind of explore where the value of optionality comes through uncertainty. So this is all a worked example. These are all illustrative numbers and illustrative scenarios. But just to explain briefly why uncertainty leads to additional value for flexibility. So what we have here is a single best view here, which is a sort of a low growth scenario where there's sort of incremental, gradual low growth on a particular point in the network. And at some point that will trigger the need for some kind of intervention, traditionally reinforcement, but maybe flex to sort of bring down demand. And that happens when peak demand exceeds capacity, simply put. We've then made up a higher growth scenario where that tipping point comes earlier, and a lower growth scenario where it comes later. And when there's higher growth, you trigger that reinforcement earlier. So rather than just paying for flexibility that goes higher and higher in that higher growth scenario, you're simply doing reinforcement earlier. Whereas in the lower growth scenario, that additional value that you're getting from flexibility can be extended into the future. So there's an asymmetry there. And that's this flexibility giving you the right to do something, but not the obligation, or letting you see what's happening in the future. It lets you. There's an asymmetry there that gives additional benefit from when there's an upside case, and that isn't matched by the corresponding downside when there's a downside case. So that's sort of what's going on here when we're seeing additional value from flexibility. So you can see, don't worry too much about the particular numbers, but if we were only looking at 1 year's worth of flexibility, that might have a value of say £25,000 in net present value terms. If we do that for the 3 years that under this particular set of numbers is optimal, then that increases to 44k. But when you look at that value across those three scenarios, and I think for all of these we're using weighted average just to keep things simple, the fact that you're revealing the ability to hit this larger value under the DFES 3, in this case, this 148,000, even sort of having the chance that that's the scenario you're in on a weighted average basis, that increases the value of flexibility. And again, that value is sort of that should be recognized in year zero at that starting point, even though you don't know which scenario you're on. So it may well be that the best view outturns, in which case what you're actually going to lock in is 44k. but given that there's a non-negligible probability that there is a higher value waiting for you by being able to do lots of years of flexibility, that under uncertainty, that value needs to be recognized in the value of flexibility itself. So that's what we're sort of getting at here, that uncertainty, when there is an upside, is worth something beyond that sort of central view. And again, remember, all of these examples are deliberately chosen so that the scenarios are sort of spreading out centrally, symmetrically from that best view. And just to illustrate that, what that looks like, so here's our 3 years of flexibility under the best view. So we do a year of flexibility, a year of flexibility, a year of flexibility, and we lock in this value each time we do that. It decreases because you're having to buy more flexibility in the later years as the peak load gets higher. But it's still positive until it's not positive, and then you reinforce at this point where the line goes red. In a higher growth scenario, so when that growth is picking up more rapidly than you expect, you're having to buy more flexibility in that first year to meet the need, and you decide to reinforce earlier because the volume of flexibility you would need is higher than it's justified by the economics of it. But there's still a positive case for flexibility. You're still getting a benefit from it. It's just lower than in the best view, but it's not lower anywhere near as much as the upside is higher in the DFES 3 version, when this is our much lower low growth scenario, where you get not only higher value in the first 3 years, but you've got this access to these multiple years following that point. And again, as I mentioned, this may well be the case where deferral turns into complete avoidance if the need to intervene on the network eventually goes away. You're buying the opportunity to see whether that's the scenario you're in, and that asymmetry is where that value comes from. And this is all, bear in mind, within the existing tool. This is how this works. So what we then wanted to do as part of last year's sort of work with the ENA was to look at whether adding these branches that I mentioned earlier on is an important step. So adding uncertainty beyond that year 0, and this is something that some organisations have been exploring, and we wanted to understand whether that made sense and how we would do that within the tool. And one way of doing that would be to use the Sem tool exactly as it is, but just to add in scenarios as if and to just add them in within the existing scenario framework. And what we could do is just take our 10 scenarios and make, in this case, 1, 2, 3, 4, 5 scenarios where there were 3 before. So we're just adding in additional scenarios effectively to sort of mimic this branching behavior. And so this is how that would work. So rather than having 3 scenarios originating in 2023 in this case, we would add this additional branching point here, and you would see that as before, there is a sort of higher growth scenario where you reinforce at that point, but there's now a new path which lets you continue to do flexibility in the long term and get that long-term benefit. Now, so that drives up the value. But then it's not surprising that it drives up the value, because you're effectively adding volatility, or adding spread to this scenario, to this set of scenarios. And as we said, when there's more uncertainty, where there's more volatility, that is going to increase the value. So it's not completely clear that that's an appropriate thing to do without making some other adjustments, because you're now adding in spread beyond what was originally in the original scenarios defined. But nevertheless, it does increase the value if we do that. So it's something to consider. As a caveat, though, modeling these scenarios in this way, as if they are independent parts of each other, using that existing SEM capability, isn't quite right, because it doesn't represent the decision that you would make at that point in the future. So coming back to this view, what we actually need to do is to represent the fact that in 2026, there is a decision to be made, and we're either going to reinforce, or we're going to do at least 1 more year of flexibility. And this reduces the value slightly in 1 of 2 ways. So if I just move on to save us time, so there's 2 ways where representing that decision point properly reduces the value. So one is when there's significant upside. So there's that very tantalizing case where you can avoid reinforcement altogether. If there is that significant upside, you'll typically make the decision to do another year of flexibility in order to see whether you are then on that path where you can avoid the reinforcement altogether. And you would do that even if the most likely outcome, sort of the 1 in 3 in this case, is a negative outcome. So sort of 2 of those scenarios have a negative outcome from doing that. One has a very tantalizing but positive outcome. If you do flexibility, you have to accept that 2 out of 3 times that would have been strictly the wrong thing to do. Had you known, had you had perfect foresight. So you need to reflect the fact that you're paying a small, probably premium in order to see what the future holds. So there's a small penalty that sort of modifies that sort of perfect foresight case. The alternative is when there's only a more modest upside, then you would take a different decision. So you wouldn't choose in that case necessarily to do flexibility because the upside is relatively small, and the more likely outcome is that reinforcement is the lower cost thing to do. So you would, in that case, by the way we're sort of setting this up, you would choose to reinforce, and in that case you don't still get the potential to see that upside if it turns out that the scenario that favored flex materializes. So you're either kind of giving up your upside in that case, or you're paying to see whether you're on a path to get more significant upside. But either way, there is an adjustment you have to make to that sort of more simplistic perfect foresight framework that I outlined before. So it's something that we could put into the tool, but we would just want to get comfortable with the idea that that's an appropriate thing to do. So this slide then summarizes sort of where we are and where we could go with this. So modeling multiple scenarios already reveals significantly more value than looking only at the central best view scenario, and I hope I've kind of illustrated where that additional value comes from. We have been asked to look at this, whether we should be looking at additional modeling, additional uncertainty beyond that year 1, so this branching structure. We've noted that simply adding branches to the existing scenario framework will tend to increase the spread and hence the value of flexibility. Now, this is perhaps a point to be debated, but I don't think that's necessarily the intent, just to drive up the spread and therefore ascribe additional value to flexibility. But as I say, that could be for discussion. But we've got sort of two possibilities. So the compatibility column in that chart there, you can see that where we are currently with the Sem tool is to have the ability to model multiple scenarios up to 10. We could do the branching scenarios treated as independent, so that's treating them as if we have perfect foresight. It's not strictly the right thing to do for reasons I think I've just gone through relatively quickly. It would also be quite limiting because we only have 10 scenarios to play with, and once you start adding branches, you run out of scenarios pretty quickly, particularly if you have multiple nodes, multiple branching points. And then the 2 methods that we want to cover in the final few minutes here is to look at how we would implement branching scenarios which reflect that decision logic, and that would involve a change to the model. And there's 2 methods we'll come to in the next phase of the slides. So we are now looking for feedback on what steps to take, if any, in the development of the Sem tool. So that's what we'll get to now. So just to reiterate, the current method, which includes the updates that came in 2021, does have these multiple branching scenarios and does, as explicitly as we can, describe the intrinsic benefits, so that deterministic benefit and the uncertainty benefit, in order to get to the total option value. And the spread of uncertainty is sort of by definition reflected by the scenarios that the DNOs choose to use, which may well be DFES, but could include other scenarios as well. And there has the advantage that those scenarios, there is a really reasonably well-established methodology for defining those. But we do want to explore 2 possible enhancements or adaptations of that current method. So method 1 is to use the branching as we've discussed. And really the question is, how do we do that? How do we define those branches? And that's what these two methods are going to explore. So method one is to say, we're going to keep the scenarios as the kind of basis on which we project into the future, but we're going to add in some additional branches onto those sort of well-established scenarios that the DNOs have been using for a number of years now. The advantage of this approach is that you're using scenarios that are well recognized, and that's the main thing. The issue is, as I think I mentioned, if you just add branches to those scenarios, you're going to drive up the spread of future outcomes. So you may need to do some calibration to make sure that doesn't happen. So that may involve branching out from the central scenarios whilst at the same time branching more inwards from the outer scenarios. And I think maybe you can sort of see where that starts to get somewhat subjective and complex to do. But it's something that we could go ahead with. I guess there are a number of questions on how that would work specifically and in practice. The alternative method, or an alternative method that we've explored, is to not do away with scenarios necessarily, but have an alternative view to the scenarios. So instead of using multiple scenarios to define these spreads, you focus instead on your best view. So this kind of green line that we've been looking at, and you say, here's our best central view of what's happening on load growth. But we want to understand how the value of flexibility is affected by uncertainty about how that load growth might evolve. So what we could do is parameterize that spread by defining some node years and defining the spread and the probability of spread at each of those nodes, and then carry out that decision-based valuation that I've already explored in the earlier slides. The advantage of this is that you don't have to be locked into one set of probabilities. You can explore how the value of flexibility changes as either the kind of trajectories evolve, whether they evolve in a more narrow or more broad way, or how probabilities change. You can parameterize everything, and you can then start exploring potentially how to layer this view onto your some more well-established scenarios to kind of get the spreads agreed, get them aligned. So that there are definitely merits to going down that road, but I think we're still left with the issue of how to calibrate these in a consistent way, and a way that isn't too subjective. So that's it in terms of the options we have been looking at, and that leads us to these consultation questions, which is, as I say, there is the option to stick with the current approach that we have in the tool, but the question is, should we take one of these alternative options forward, and if so which? And indeed, are there any other approaches to calculating optionality that would be better suited, that we haven't necessarily covered in our exploration to date? And so yes, we'd certainly be interested to understand what thoughts are out there on that. And we're on to poll and questions again.
Absolutely. Time for the next poll. So this poll is going to ask you about optionality and what approach you think the Sem Tools should employ. So same thing again, if you would like to have a look and vote, remember to get out of your full screen mode. The questions are: multiple scenarios as per the current Sem and tool. Method 1, branching off a scenario, and method 2, branching around a single scenario. And dare I say, the don't know question. So again, back to that, ladies and gents, you'd like to vote, please vote now. Which optionality approach do you think the Sem tool should employ? And again, I'm just going to, while we're waiting for people to answer, let me just bring the team back in. One question that probably relates to that, actually, someone's put a question in here, and again, I'll leave it up to you guys to decide who answers this. Branching is very limited. A Monte Carlo model, I don't know what that is, I'm sure you do, ensures that thousands of scenarios are investigated and captures those high value edge cases. Also Monte Carlo benefits from having only two subjective inputs, the mean and the variance. The chem can be easily adapted to incorporate a Monte Carlo demand model whilst retaining the commercial comparison part of the model. Who'd like to answer that?
Simon, you're on mute if you're talking. Are you kicking it over to me?
So I was suggesting that you should answer that question, Chris.
I mean, in a sense,
I don't know what a Monte Carlo model is, Chris. So you can, apart from, unless it involves wearing tuxedos, I'd like to know.
So, Monte Carlo approach, effectively, you're defining a trajectory based on a set of input parameters, and then you randomize each of those parameters independently of each other, and you rerun and rerun and rerun. And you get lots of different possible futures defined by a sort of relatively small number of input parameters. So it lets you sort of explore the possible future space in a more in their hundreds, in their thousands, with relatively low.
So how do you answer the point that branching is limited, and that would be a better way of using it?
It may be a compatible approach. I think we would need to think about how the Monte Carlo approach works with that decision tree structure, because what you'll end up with is 1,000 trajectories, but you still need to model the decision-making point that you're making on each of those trajectories. I'm definitely not saying it doesn't work. So I don't know who that comment's coming from, but we would certainly be interested in. Well, I can't speak for Simon. I shouldn't speak for Simon, but I personally would be interested in understanding sort of how to marry those two ideas, because it's definitely appealing.
Okay, and we'll do one more question, which is quite an interesting one. Someone's just said basically, now how is the value of this all going to be shared with the consumer?
So I guess prior to tendering, a lot of the DNOs now issue either a maximum price or the ceiling price of what they're willing to pay as part of the tender for flexibility. So it is used primarily as a guide price to the DNOs in their tendering process to what would be the economic value for flexibility, or up to the economic value for flexibility. And then all the DNOs, once they get all of the bids back from all the providers, they will then rerun the chem tool and see which are the ones which are most appropriate, whether that's one, whether that's multiple providers, and then the different technologies, because the tool can effectively look at different flexibility technologies dependent on the carbon impact of them. So it can be rerun again to actually then for you to decide which flexibility type or providers that you want to then purchase going forward. So you can use it pre and then post tendering.
All right, let's go to the poll. I think we've had pretty much most people who have been involved. We have got something better for you guys this time. Here we go. So multiple scenarios as per the current Sem tool, 8%. Method 1, 28%. Method 2, 24%. The don't knows still win at 40%. So there you go. So again, clearly this is good because it means there's quite a lot of room for you guys to maneuver. Let me hand back, I think, for you, Chris, before the end of wrap up from Simon. Is that right?
I think I'm done.
Oh, are you done?
You'll be glad to hear.
Simon, do you have any more slides to go through?
Yeah, I think we've got one more or two more slides, I think
there's a couple more, yeah.
Yeah, I think there's a couple more. Yeah, so really just what I'll do is spend a bit of time on just reminding everyone that there is a live consultation. The snappy title of it's a consultation on valuing optionality in the common evaluation methodology. It was published today. The consultation closes on the 8th of April. Usual way of responding is via the email address on the screen. And the plan for the product team is once we've had an opportunity to review the comments, we'll publish a summary. And then around late May or early June, then we'll publish the next steps once we received your feedback. And at the bottom, they've just got the consultation questions, primarily a repeat of what we just asked in the poll, but more of a just broader question of, is there anything that any of our stakeholders think that we should develop the Chem tool, and if so, how we should develop and in what area, and if there is more than one area, then to rank them in order priority. So it is trying to be a bit more, can we have your views on how the Chem tool should be developed, where it should be developed, please, because we, we've spent a lot of time in this last year looking at optionality, possibly to the detriment of some of the other things that potentially people would want us to look at. So it is not just about optionality. We're happy to receive any of the feedback or comments on areas that our stakeholders think the Chem tool should be developed. And then I think there's just a summary slide just on the list of questions. So we're all done now.
All right. So look, we haven't got very long. We've got about 4 minutes, but there's a couple. I want to fire through some quick questions. And obviously, remember, ladies and gentlemen, you can download this afterwards, and you can see the links to all of this. Someone has said, is the Chem tool publicly available?
Yes, it is. It's on the ENA's website on their resources library.
Okay. Another one, maybe this is someone's tried to download the tool. It says the download doesn't work. Can you please post the direct link? We'll make sure that link is published on our site. Yeah.
Yep.
Avi, we can't hear you.
I was just going to say, I'll look to include that in the slide deck when you send this across. I'll include the tool along with the associated reading material that goes with it.
Okay. Another quick one. Is the ceiling price for Flex linked to the ceiling price for reinforcement?
The reinforcement value. So if anyone opens the actual tool, what you'll see is the value of the reinforcement cost is one of the input parameters. So there is obviously a link between the reinforcement value and the ceiling price. But as Chris kind of described in his summary, there is quite a detailed way of getting to the ceiling price. A number of input parameters are required for you to calculate the ceiling price.
Another one. So far, scenarios model option values for Flex. Will the Chem tool also cover price for demand response Flex close to real time the next day?
That is potentially one of the future developments that the product team need to think about. So the way the tool is currently being used is it's about the purchasing of flexibility in advance, generally 6 months to a year in advance. One of the changes that's required in the industry is with the increase in flexibility and the competitive nature of flexibility. So as volumes grow, price will probably be keener. We will be required to move to more of a dynamic purchasing of flexibility, whether that's week ahead or day ahead. And therefore, there is a need to actually have some type of version that allows you to do that analysis short order to give you a decision about what it is that you're going to do in the periods that you need them, whether that's a week ahead or a day ahead.
And probably got time for one more. Would you agree the third alternative might involve a broader dialogue with the DNO, for example, by local authorities, system actors, which could benefit or rely on a deeper dialogue about scenarios and projects? That's quite interesting about working with particularly local authorities, who will be really obviously at the heart of what we do regarding public sector flexibility.
Yeah, and to be honest, the industry is, they've already started that journey. So you'll find on the majority of DNO's websites all of the information on their DFAs and their scenarios. You'll be able to download all of the data that is published in the background for their forecasts, for their scenarios. And in the ED2 business plans, all of the DNOs have committed to work with the local authorities in developing local area energy plans, which the scenarios will be a great help to actually understanding how I guess collectively we can work towards those net zero aspirations that we have as a nation.
Excellent. I'm really sorry, ladies and gents, we are out of time. So very briefly, thank you very much to Simon, to Chris and Avi, although Avi didn't have too much input, but thank you very much for joining us. You'll be able to download this, and I'm sure both of you, if I can just, I think hopefully pull up the last slide. This is the email, opennetworks@energynetworks.org, correct?
Yep.
So if you've got any questions, send it over to that email. You'll be able to replay this at your leisure, and I'm sure both Simon and you, Chris, are happy if we get any questions from our audience, if we can pass them on to you directly. Is that right, to all of you? Then we will do. Thanks for watching, ladies and gents. It's been a pleasure to host this session. Please rate it. And have a fantastic afternoon. Gentlemen, thank you very much for your time today.
Thank you.
Cheers.